Hi, in this video I'm going to show you how to find the slope from a table. Remember, slope means rate of change. It also means unit rate. In geometry, it's called incline, and we also use the letter m to denote slope, especially when you see the equation y equals mx plus b. Now, slope from a table, let's say we have a table of values where the domain is 8, 11, 14, 17, and let's say the range is 36, 12, negative 12, negative 36. We want to find what pattern is happening between the y values and what pattern is happening between the x values. We can see that the y values are decreasing, and we can use subtraction to find out by how much the y values are decreasing. So we can do 12 minus 36. You usually use the second number minus the first number to start seeing what the change is. And we can see this is negative 24. We can check if the other numbers are also changing by minus 24. So we can do 12 minus 24, and we see we get negative 12. So that means, indeed, the y values are decreasing by 24. Then we look at the x values from 8 to 11. That's increasing by 3, and so are the rest of the x values increasing by 3. Now, for slope, we want to know unit rate. So we want to know how the y values are changing, not by intervals of 3, but by intervals of 1. So we have to use division in order to find that. The definition for slope is the change in y divided by the change in x. So the y values were decreasing by minus 24. The x values were increasing by 3. So we can do negative 24 divided by 3, and we get negative 8. And that is our slope, or m value. We can use that to write an equation. This would be like y equals negative 8x, but we would have to find the y-intercept, which I will show you in a different video. Okay, now it is important to note that when you're looking at tables, it might not seem like the y values and x values are changing in a linear fashion. That's why it's important to use the slope formula to verify the slope. Let's say you have a table of values such as so let's say you have something like your input is 10 while your output is 15. When your input is 20, your output is also 20, 40, 30, and 50, 35. So we can look at, okay, how are the y values changing? We see this one's adding by 5, but then here we're adding by 10, and here by 5. So it doesn't look like it's linear, because linear functions, you have to add or subtract by the same amount. But it is important to also check the x values, because they might have been skipping. And so we need to verify that. This is plus 10, this is plus 20, this is plus 10. So we have to actually use division to see if the slope is the same in each interval. So we're going to divide our change in y divided by the change in x. So here, for the first interval, y changed by 5 and x changed by 10. That's 5 over 10, which simplifies to 1/2. Then, the second interval, we have y changing by 10 and x changing by 20. But 10 over 20 is also equal to 1/2. And then again, we have 5 over 10, which is 1/2. So even though it didn't look linear, it actually is linear. And dividing the change in y by the change in x shows us that, yes, the slope is always 1/2 in this function.